All right, so this is kind of a fabulous problem, but it does take kind of forever to do. So we've got these little bearings. One of the first things that we want to notice is it says that they're in proper alignment. So, for example, on bearing A, we would have a, let me try to draw in a little kind of like this just for a second. I'm going to have motion that's prevented in this direction, and I'm going to have motion that's prevented in this direction, and ordinarily I'm also prevented from having rotation in this direction and prevented from having rotation this way, but since it says that the three bearings are properly aligned, that means that no rotation is going to occur, so I don't have to worry about drawing those in. So it's actually very helpful. So I have some A in the X direction, and I have some A in the Y direction. I'm going to go ahead and delete those extra lines just to for funsies. All right, so then again in B. All right, so I've got a reaction here, preventing motion in this direction, and I'm preventing a motion in this direction. And again, I don't have any reaction moments because I have properly aligned bearings. So this is BX. Okay. And then here again in C, I have prevented motion up and down, and left and right, or X and Y, or in the Y direction. So I have C in the Y, and C in the Z. So that's amazing. Yay! Okay. So really this is just kind of a mathematical beast. Whenever I look down here, I can go ahead and I can break this out. So I know that this little term right here is going to be F sine 45. And this is going to be F cosine 45. And since that's the hypotenuse of this triangle here, this one here is, that's going to be sine 30. So F, that's the hypotenuse, and then sine 30. And then this one is going to be adjacent, so it's F cosine 30, cosine 45. Because that's the hypotenuse, and then cosine 30. So I'm going to go ahead and write F out because that's the one that's freaking me out the most. So F is going to have a positive X direction. So F cosine 45 sine 30. And it's going to have a J direction. That's this one. This one's in the J direction. F cosine 45 cosine 30. Something like that. And then finally, yes, duh. Okay, wait, negative. I'm thinking about monkeys. This would be negative. Sine 45. Like that. And this looks like a C. That thing. Like that. Woohoo! Okay. So since I have that written, I'm going to go ahead and erase all this other junk because it's just scaring me. And now I have that for later in case I need it. I'm actually going to move these off the screen, but I wanted to have them there so you would be able to see them. I'll zoom out in a second after I'm done drawing pictures. But I have that for later because I'm going to... Ah, no, stop. Whatever you're doing. Stop it. There we go. So, next step. I can take all some of the forces in the various directions. Well, let's do this one because it's cute. It tells me that F1 is 150. So this is going to be, well, this F1 is going to be 150, well, really 75 square root of 2, because it's 150 cosine, whatever, square root of 2 over 2 of 45. So the it's going to have nothing in the X direction, and then in the Y direction it's going backwards, and in the Z direction it's going down. Okay, so that one's totally in the box. You can see all of that. Okay. So now I'm going to zoom out a little bit because I've kind of taken care of the scary stuff. And I'm going to do the sum of the forces in X. Okay, so in X I have F cosine, I'm just going to write instead of f square root of 2 over 2 times 1/2 because that's sine of 30. So that's x. I have nothing from f1. Then I have ax. Then I have bx. And you still can't see what I'm doing. No, that's the opposite. That's 2 times ax, bx, and, well, that's it. I just have the 1, 2, 3, 4, 5 forces. 2 of them are not helpful. Okay, so that equals 0. Then I have the sum of the forces in the y. So that's going to be f cosine 45 cosine 30. All right, and then minus 75 square root of 2. And then what else has y's on it? AY and CY. Then I have some of the forces in the z direction. Okay, so that'll be minus f square root of 2 over 2. And I'm only doing that because it saves space and I care. And then other stuff in the z is the negative 75 square root of 2 plus bz plus cz equals 0. So I have 3 equations, but I have like 1, 2, 3, 4, 5, 6, 7 unknowns. 7? Gosh, I hope not. Oh, wait. There's something else that we forgot to see. It says the bearing at C is 0, so these are all 0, so I can get rid of anything that says C. That's amazing. Okay, it's like, how are we going to solve this? So those go away like that. How fortunate. Now that feels better. So I have 1, 2, 3, 4, basically 5 unknowns. Oh, it's just a stupid CY one. Never mind. I thought we were getting off too easy. Let me put those back in there. Darn it. This is what I get for, you know, being an engineer. All right, pa-chunk. So just the CY is 0, so I still have CZ. Well, you know, at least I figured it out before with the whole problem. Got everything wrong. Okay, so CZ plus CZ equals 0. How's that? We happy now? I think. Okay, so now I have 1, 2, 3, 4, 5, 6. This is my 6th unknown. So I have 6 unknowns, but only have 3 equations. That means I need to have more equations. Okay, so I'm going to start taking moments. I'm going to take the moment about, I don't know, maybe O. Or like the origin, I mean, like this one here. Take the moment about O, because it seems useful. So let's take the moment about O running through the x-axis. So I want to do the x-axis one. And the x-axis. Okay. So who's causing a moment about x? So let's start off with this guy up here. So he is clearly causing a moment. Both of his components are causing a moment. So this little component is making me go woo-woo, and this little component is making me go woo-woo. So those are both going to be positive moments. Two woo-woos. So the first one, if I do this one right here, that's positive 75 square root of 2, and it is a distance of 5. It is a distance of 5 away from the x-axis, so times 5. So it's 5 away from the x-axis. Now, this other woody-woo here, this guy, he's also a positive moment, so 75 square root of 2, and his distance is 5 as well. Amazing. Okay, I feel like I should have been able to do that faster, but it doesn't matter. We're done now. So, and if you're ever confused, remember that this first one, this was a y component, so that means that the 5 has to be a z component, which it was. It was this one. Now this one is our z component, right? It was this guy. This is a z component, so it has to go with a y distance, which it did. Okay? And that's because we're making an x moment, so that means the only terms that can go into the x moment are z and y. Amazing. Okay. So now that I'm going around and I'm looking at the other forces, so I took care of this force up here. This force is good. I don't know why I'm coloring everything. It's just fun. Okay, so now let me look at this force. So is this force causing a moment about the x? No, it can't, because it's an x force. An x force can't cause an x moment. But this guy here is making a roundy round this way. So that's going to be a negative force. So negative ay And since this is a y force, I'm looking for a z distance. So that z distance is 4. It's 4 up. It's 4 off of the x-axis. So times 4ay. So that one's good. Please remember that since this is a video, you can pause it and rewatch it as many times as you want. X does not cause a moment, but z does, like that. So I'm going to have, and that's a negative moment, so minus bz. And since that's a z component, the distance needs to be a y, which it is. I'm 3 feet away. Yes. So, like that. Okay, and then I'm not going to get any contribution from C because it's collinear, and I'm not going to get any contribution from O because it's collinear. So that's kind of a nice little trick or fun thing to do. Okay, stretch. Oh. Pop my knuckles. Do the next one. Some of the moments of O. Now I'm going to go about the y-axis, running through O. Okay. So in this case, this guy isn't going to contribute because he's collinear. This guy isn't contribute because he's a y component. And this guy isn't contribute because he's a y component. So the first one that contributes is ax, and ax is going to go woohoo like this. So that's a positive. Ax, and since this is an x, and I'm going about the moment about y, this other one's going to have to be a z component. So it's 4 up. So it's 4 off of the y. Oh no! Don't do that, please. I need you there. Okay. So I've taken care of those 3. B is not going to cause anything because it's collinear. F's not going to cause anything because it's collinear. So the only thing I have left is CZ, and CZ is going to go woo this way, which is positive. And that's a Z component, so that means the guy that goes with it has to be an X because it's about Y. And so its X distance is that thing, 5, but I just crossed it. And so that has to be equal to 0. Woohoo! Okay. Now, one more. Now I'm going to do the sum of the moments of O along the z-axis. Wait, that's not a z. This is a z. That doesn't look very fun, but okay. I'll do it because I'm committed at this point. I'm not totally committed, but it'll be fine. I can power through. It doesn't look as much fun. Okay, so this one is not going to contribute because it's a z, but this guy is not going to contribute either. Wait, because it's runs right through the, does it run right through the z? Seems like it does. It's collinear. There's no, it's a y, but there's no x distance. It's not, oh wait, so great. Neither of those contribute. This is amazing, except I just deleted all my a's. Did I delete those a long time ago? I just didn't notice. Apparently I did. Try those back in. Okay. I'm amazing. At least you don't have that problem if you're doing it on like a real piece of paper. So this is A, this is A. Okay, so AY is not contributing. The other ones aren't contributing. So the first guy that really contributes is this one. She contributes because she goes woohoo, and that's a positive moment. So plus AX, and since that's an X component, then the distance is going to have to be a Y distance. So her Y distance away from here is 5. That distance 5. So 5. Now, let's see. BZ can't cause a moment because it's, you know, Z. And it's parallel, but BX can, the same way that AX could. So BX is also going to go wee, and it's still going to be positive. And its distance is going to be a Y distance, which it is, which that's a 3. So its Y distance is 3, like that. Beautiful? This is turning into a long problem, and I actually know what I'm doing. No wonder you guys are frustrated. But frustrated doesn't mean you weren't learning. Okay, clearly nothing at O is going to cause a moment, and this guy can't cause a moment because he's already at CZ. So, yay, we've got something. Okay, 15 minutes later, we might actually have something we can do something with. So what I'm going to do now is I'm going to rewrite this, where I'm going to line up all the I'm going to put all the AX's in the first column, all the AY's, then all the BY's, and then, or X's, what do I have? I don't remember now. Whoa, I'm way too far down. I don't need to work that hard. Basically, I'm going to go AX, AY, BX, BZ. So I'm just going to rewrite them where all the variables line up. I'm going to do F, and then I'm going to do CZ. CZ, and then all the constants are going to be on the other side of the equation. Okay, so for the first one, I'm going to have 1AX plus 1BX. So 1AX plus 1BX is, or plus square root of 2 over 4F equals 0. So I've got 1AX plus 1BX plus square root of 2 over 4F equals 0. Now if I mess up like one negative sign, I'm just thrashed. So I want to try not to screw anything up. Okay, now for the next one, I've got 1AY. So that's equation number 1. I'm really afraid of messing this up. Okay, 1AY. And then I have square root of 6 over 4 for the F. And is that positive? Yeah, those are all positive. And then I have negative square root of 75 over 2. So if I move that over, it's going to become positive 75 over 2. Whatever I said, that's what I meant. So that's going to be 75 root 2. Okay. I'm going to do the next one. Okay, so this one will be plus BZ, 1 BZ, 1 CZ. 1 BZ, 1 CZ, negative root 2 over 2F, negative root 2 over 2F, and then this root thing goes on the right, so it'll be positive 75 square root of 2. Alright, more. This one looks more complicated, so I'm going to make this a little bit smaller so I can see it without scrolling up and down all the time. I have to write smaller. Okay, so for this one, alright, this is a constant, so it's going to go to the other side, and this is a constant, so it's going to go to the other side. So these two are going to get moved to the other side, so it's going to be like whatever 75 times 5 is. Of course, I'm going to get these hard problems. 75 times 5 times the square root of 2, but there's 2 of them. Yes, there are clearly 2 of them. So it's going to be negative 750 root 2. Negative 750 root 2. And then I have a minus 4 in front of the AY. And I have a minus 3 in front of the BZ. Okay, now for this one, this is actually kind of nice. I have a 4 in front of the, I'm just going to keep drawing these lines to make sure I stay lined up. I have a 4 in front of the AX. I have a 5 in front of the CZ, and then all equals 0. And then I have a 5 in front of the AX. And a 3 in front of the BX, and then that equals 0. Okay, now theoretically, if I fill all this other crud in with zeros, and I haven't made any mistakes, and I don't make any mistakes when putting this in a calculator, I can now plug this matrix into the calculator and solve for 6. No, not that far. There we go. Okay. And my answer should come out. So, let's try this. Pachonk. 1, 0, 1, 0, square root of 2 over 4. 0, 0. Pachonk. Okay. 0, 1, 0, 0, square root of 6 divided by 4, 0, 75 times the square root of 2, the chunk. I'll have to check all these in a minute. 0, 0, 0, 1, negative square root of 2 over 2, 175 square root of 2. Pachonk. Ah, there's nothing in there. And I did something weird over here. What is that? I don't even know what that was supposed to be. I think that's supposed to be square root of 2 over 2. I'll check. Okay. 0, 0, yeah. 0, 0, 0, 1. Root 2 over 2, 1. Okay. Alright, next line. I think I know what line I'm on. 0, negative 4. I can imagine how fun this is for you to watch me do this. 0, 4, 0, negative. No, not that. Negative 3. 0, 0. Negative 750 times square root of 2, I believe. Yeah. Pachonk. 5, 0, 3, 1, 2, 3, 4. Please let this be a matrix. Ah! Okay. Oh, is it because I did a negative instead of a negative? Okay, now I actually need to go check these because this would be really, really bad if it's wrong. 1, 0. That top half looks okay. Doop. Oh, that's not right. Because that's supposed to be root 6 over 4, not root 6 times 4. Amazing. See, it's so much easier to do on a real calculator because this is actually very annoying to listen to the click, 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 click. Okay, square root of 6 divided by 4. Let's try it again. Really, is there no better way to see this? Root 2. Did I have it a second ago? Hold on. Okay, so rather having you watch me spend 10 minutes figuring out what I did wrong with my calculator, which is I skipped a level, I skipped an entire line, now I'm going to reverse row echelon the correct value. And as it thinks about it, I start to get something. So here I see if I go up, I start to get values. So I have 178, negative, well basically 179, negative 100. Negative 298, 487. 337. Now I can't find the last one because I can't figure out how to make my stupid screen do that. But if I hit enter, there's the last value right there. Negative 140 to negative 143. Like that. Negative 143. So those would be the values that I'm looking for. And aren't they lovely? That was kind of a beast, but really the beauty of it is actually figuring out how to get all those things kind of organized the way that they need to be, and then sticking it in and just wanting it bad enough, I guess. So I hope that was fun.